Hey everybody. So yeah, I don't think I can give you a true audio test other than this. Starting it. You guys hear okay? Hear anything at all? Okay. Yay. Sweet. So that's good. Check. Audio test is good. Yeah, we just figured we'll give any stragglers a couple minutes still, just in case. But while we're on here, yeah, feel free. I think there should be at the bottom, there'll be a ask a question. And from what I understand with Crowdcast is that like you can upvote certain questions. So if you're like looking at that list and then you have a similar question or something, you can upvote it. So that way then maybe we don't have any repeat questions or whatnot. So anyway, yeah, so again, we'll just give it a couple more minutes and then we'll get started. So you guys can just see me like I work all day. New phone, who dis? That gets an upvote. Oh, also too, one of the cool things on here as well is there is the ability where like if you have a question, I can invite you to the screen and then you can actually speak your question to everybody. Yeah. So that's kind of cool too. All right. Well, my Mac says it is 6:05, so I guess we're going. Let's do this. So anyway, welcome everybody. My name's Paul Baylog. I'm a cloud platform team lead for NISC. And this is the first virtual St. Louis Go meetup. Yeah, so keeping our social distancing going and not meeting in a group. Not physically anyway, but there's always a way around it. So anyway, yeah. So again, my name's Paul, and we have our other, if I can get this thing going here. Okay. Our other members of the steering committee, they're also online here, but we've got Sabri, he's waving there in the chat. We've got Brandon Hunter, who's also on with us tonight. And then Siju John. And I'm not sure if I saw him on here yet. He might, I don't know. He was saying that the pizza was getting delivered for the meetup, but it's just going to his house. So unfortunately, we're missing out. Not cool, Siju. So, all right. So yeah, as you know, as you figure, the venue denied, food denied, the giveaways denied. So, but we do have the meetup fees are met by GoBridge, so we're thankful for that. And then, and actually, they are working on getting a platform that we can use going forward as well. They're talking about, I think, Big Marker, possibly even a Zoom education setup, but I don't know. We'll see. This one seemed pretty cool. I checked it out, so we'll go with it. So anyway, one of the things that I like to do is try to just get kind of as much interaction as possible, and then like what's going on in the whole Golang world. So anyway, we'll go through a couple things, and yeah, the big thing it's a slow news month, really, for some reason, but yeah, this ends up. It's our second birthday for the meetup group. I haven't been for all of them, but Charles, he started this back in 2018. So happened to look through the all the old slides, and there it was. It's 2 years old now. So woohoo. So yeah, it seems like everybody's working remotely. I am, I know. Don't isolate alone. Catch up with us on the STL Tech Slack. The the Go channel. Keep up there, communicate. Let's figure out some more stuff to come up in future sessions and whatnot. But yeah, GopherCon, I was hoping to actually go this year. It's postponed, so we'll see. Not sure when we're also going to be, when they're going to try to reschedule that, but it's unfortunately lacking. Oh, yeah, Brandon mentioned there's still pins and posters, yeah, from the 10th anniversary for the Go language. So if anybody wants a poster or one of these pins, Brandon's got a box of them. So just hit us up. You can DM us even on the Twitter account, or just even drop something onto the meetup, just a comment or whatever, or in Slack or yeah, whatever. You can get a hold of us easy. Yep. And he's going to provide some pictures of them. All right, so let's try this. I don't know. Anybody has something they want to bring up? We can try this out and see if we can invite you to the screen and you can bring something up. I don't know. Or you can put something in there. So anyway, otherwise, going, gone? No, nothing? All right. Sorry, lost focus on the right screen there. All right, well, I will then turn it over to Michael and our presenter for this evening. So, Michael, you got it, man. You want me to just bring up your screen there?
Yes, please.
There we go.
All right, thank you very much, Paul, for the introduction. As Paul said, my name is Michael Madden. I work at Elastic. My title is Senior Software Engineer, but I do more DevOps work. I don't do a lot of like what you would think as a traditional software developer. The team I work on is the Beats team, and their primary language is Go. So I get exposed to a lot of Go. I don't do it a lot day to day. I tend to do more stuff like Docker, Makefiles, Jenkins files, things like that, CI/CD kind of setup and release setup for the Beats team. But cybersecurity is something I'm interested in. So I thought this was a good follow-up, kind of apply some of the knowledge I've gained on the Beats team and just explore some of the interests I have in cybersecurity. Hopefully you can see my screen with Visual Studio Code.
Yeah, Michael, looks like they're hoping to get the font to be a bit bigger.
Yeah, you bet. I'm jumping up a couple more. Is that okay? I jump back. I can't see the comments. Better? Okay. It's like crazy huge on my screen, but evidently it's small on yours, but that's fine. Just some upfront qualifiers, like I was alluding to. I'm not a seasoned Go professional. This is something new. I'm learning. It's so I mean, some of the code you'll see later on might not be the most efficient or performant way of doing something. If you see something that's way out of whack, please let me know. I'd like to learn and make it better. Another qualifier is don't just blindly run the code or don't blindly execute this. Kind of trust what I'm doing. Don't assume that it's okay. I mean, just like you wouldn't blindly go download some executable from the internet and run it. Same goes here. The content of the code here is just for demonstration purposes, just for my exploration or maybe to inspire others. It's certainly not for production use or just more for educational and learning. Again, don't use this code or the resulting binaries against systems you don't have authorized content on. That makes sense. So it's like you don't want to attack other organizations or bring down other organizations' infrastructure. And item 5 there is just be smart with what you do. I mean, everybody is probably a professional or been around at least for a while. So be smart with what you do. Feel free to jump in and ask questions. If you have questions, I'll try to answer them right away if I know, or like Paul can have you jump on the screen and you can ask them. Some of my inspiration for this project was Sabri's presentation he did last fall, which was Go Crypto by Example. And there's the link there. That was definitely focused on Go and cryptology, but mine is a little more on some hacking tools, and those were, the book has a ton of them, but I focused on a couple from the recent No Starch Press release of Black Hat Go. It was released earlier this spring, and I had previously read parts of other Python books like Violent Python and Black Hat Python, but some of the stuff in Python I love. It's easy to get things going really quick, but then other things it's hard to distribute your code. It's tougher to do that, and it's not a single executable like it is with Go. Often the performance of your Python application is a little lacking. So some of the nice things about Go that attracted to me to make some security tools was Go is pretty simple, user-friendly compared to some other statically typed languages. The one I had in mind was C++. I have friends that love C++, but I tend to be a more simple person. It's hard for me to keep all the syntax and all the structure in my head. So the people that tend to like C++ tend to be smarter than me and are maybe more language lawyer kind of people. But the appeal was with Go. It's pretty simple. I can easily wrap my head around it. Kind of another item I alluded to earlier, like compared to dynamically typed languages like Python or maybe Ruby, the Go performs better since it does compile to a executable. It's generally quicker. Something like item 3 there, where Python really isn't designed for multi-core environments, with the GIL, where Go was designed for multi-core environments. Item 4 there, like Python has pip, and Ruby has gems. I think Go has a decent package manager in Go Git. It's pretty easy to go grab Go code from another project on GitHub or another source repo. That's pretty easy. I mean, stuff like C and C++, those are notoriously bad with not having an integrated package manager, and others are great. Like Rust has cargo, and that's really good. So Go's is decent as well. One of the nice things I like as well about Go is it's easy to cross-compile the applications. Like generally, I develop on a Mac or Linux, but if I wanted to build my binary for a Windows machine, I could easily set a few environment variables and then run Go build, and it would produce a Windows executable or a Mac OS executable or a Linux one or any of the other operating systems that Go has support for. One of the other things I really liked about Go is it's got a decent standard library. It has networking libraries. It's got encryption libraries. It's got all the things that you would hope for a language that has like batteries included. A lot like Python has a lot of built-ins. Ruby, these languages that allow you to do things quickly. A lot of the stuff is built in, unlike C and C++, where you're building a lot of the things by scratch. And item 7 there, I've kind of alluded to this already. If you build a program in Go, it gets compiled to a static binary, and then you can take that static binary and run it on any similar platform. Like if I build it on my Mac, I could easily send that executable to Paul, and he could run it on his Mac without having to install a bunch of libraries with, like, an example of Python, you might have to pip install a bunch of set of libraries, and then Paul might not even have Python on his Mac or his Linux box. So it's really easy. You just ship a single executable. And then one of the other things I really like about Go, it tends to be pragmatic. It's I think they try to get things done instead of just being extremely theoretical or scholarly about things. They tend to solve problems and not worry too much about the theory or maybe the one best way to do things. They tend to get things done, which kind of matches my mindset as well. One of the last things I really like about Go is the compile times are really short. The compiler is crazy fast. So I mean, you can build a large project in a few minutes, where some of the other complex languages like C++, the build time is notoriously slow. There's a few things that could be hang-ups compared to other languages. The first thing, since Go builds things into static executables, the binaries can be pretty large compared to C++. Like the binaries I'll show you tonight, like for most of my simple examples, are in the 2 to 3 meg examples. They're in 2 to 3 megs in size, whereas like a similar C program would be, maybe kilobytes in size. Definitely wouldn't be measured in megs. One of the things that kind of rubbed me wrong when I was first learning Go is I can get a lot done pretty quickly in something like Python or Ruby, and then it took me longer. It took me more code to do it in Go. The end result was usually a little better, but it usually took me longer, just because I think it's a little more verbose. It's not to the verbose level of something like Java, but it's not as compact as something like Python or Ruby or another scripting languages. Go is still relatively new. It's not 30, 40 years old, but I mean, it's 11 years old. This year it'll be 11 years old. So that might be somebody's hang up, but I mean, it's compared to some languages, it's still relatively new. And then number 4, the package manager, like an official package manager, like Go modules. It took a while to reach prime time, and a lot of people still haven't adopted Go modules. I mean, there's been several package managers like GoDep and several other ones that were supposed to be the way forward, but it looks like with Go 1.14, it looks like Go modules will be finally the way forward. And this last one, if you're thinking like in embedded systems, something like TinyGo might be better, or something like C might be better, as opposed to doing something in Go where the binaries are really large and it's not really as easily designed for an embedded system. Any questions so far? Paul, have you seen any on? I can't see the chat, but
No.
Anybody?
Not at this time.
Okay.
I think I might have heard a groan from Sabri when you mentioned about Go modules and 1.14 being prime time.
Yeah, we kind of hit on that last month. I think Sabri was of the opinion they're not truly ready yet. So. Yeah, he was saying wait.
Literal moan, I'm sure.
Yeah, definitely with something new, like with Go 1.14 when it comes out. Sabri was recommending to hold off until one of the later dot releases, not go for the 0 or 1 release. So if there's no questions, I'm going to continue on. There's a general kind of accepted standard for doing penetration testing, and it involves these 7 steps. I'm not going to hit on all these. This would be what you were doing if you were doing like an official pen test for an organization, or even against your own equipment. I'm going to focus on all the tools that I'm going to show you tonight are in the second phase here. They're intelligent gathering tools, and they're basically just trying to gather as much information as you can about a given organization or a given target. And so the book covers a lot of these steps, but I'm going to just focus tonight on the intelligent gathering one. If you want to learn more about, one of the accepted standards for penetration testing, you can click that link, and this kind of gives you just a brief overview of it. I mean, start with pre-engagement, then intelligence gathering. That's what I was going to focus on tonight. Threat modeling, vulnerability analysis, exploitation, post-exploitation, and reporting. So I think the book covers a lot of these, minus maybe the reporting phase here at the end and the engagement phase. So they cover 2 through 6. But feel free to pick up a copy of the book. I haven't read it all myself. I've read several of the chapters. But yeah, it's a pretty decent book. The one of the tools I'm going to show you tonight, it was a DNS enumeration tool, and let's see. No, I have the wrong slide. This one here. All right, I have an error in my markup. It is not a DNS enumeration tool. This is a port scanning tool, and it's modeled after Nmap, which is probably one of the most popular port scanning tools out there. This Nmap is written in C++. There's a great link here for the Nmap primer. And then my code examples that I'm going to show you, they're in this repo here under the port scan directory. So with Nmap, for example, if you wanted to test the first 1,000 ports against a host, you would use something like this: nmap-p, and then port 1 through 1,000. And then here's the host that you would want to scan. And this one, if you go to this address and a URL, it's the authors of Nmap have set it up just as a test machine out there that you're free to scan several times a day. And then they trust you that you're not going to overload the machine, you're not going to do anything malicious. So if you run this example, this is totally legit. If you go to this page, the authors of Nmap will tell you this is fine. And then you'll see that on scanme.nmap.org, it has a couple of ports open, which is TCP. Oh, click the link there. Let me go back. Sorry. Don't click the link. All right. And if you look, it has a port 22 TCP, which is SSH. It has port 80, which is HTTP. And then these other ports, a lot of these are Microsoft protocols that a lot of these are filtered out. And then this last one, 593, it's also filtered out. So I wanted to model a program that would give me similar output to Nmap in a simple case. I mean, Nmap is like a crazy tool for doing all kinds of network scanning, but I was just going to solely focus on TCP scans, and the resulting program that I developed was something similar. I started out and just iterated on this program. It's called Port Scan, and I did like the final version. It was like version 8, and then I used a similar host, scanme.nmap.org, and it came back with the ports that were open, port 22 and port 80. I don't have the filtered ports on here, and so that's an example of the tool. I can kind of walk you through the code. Some of the early examples are very rudimentary, and I'll kind of show you how I progressed on the tool. So my first version of it, it was extremely short, as you see here. I'm just using the network package here, and I say net.dial, and then I'm going to use TCP, and I see the host and then the port, and then if there's an error, I print it out. So if I run this, please tell me if you cannot see this output. So if I run it, as you can see, nothing's output. There wasn't an error. So that was my most simple first example. And I'll go through all these examples. They'll keep on getting a little more complicated. So in this second example, I went through and I caught what the local address is. In my connection, I print out the local address and the remote address for the connection. Other than that, the program is pretty much the same as it was before. So in this case, this is my local IP on my local home network. It came up with this randomized port, and then here's the IP address for the nmap.org host that I'm on, and I'm connecting to port 80. So that was just slightly more complicated than the original one there. Let me jump to the next one. So in this, the next example here, I used the flag library to supply the host name and the port. So it defaults to this host. It defaults to port 80. But if we want to, we can specify other ports. And a large portion of this code is the same. You see the net dial is the same. The local address, the remote address, that's the same. And this error handling is the same. So I'll run that. And it'll say, all right, so give me a host and a port. So if I did, I'm going to just use localhost for right now, and I'll try port 80, and I would expect this to fail. So yeah, in this case, it's going to try to connect to my local machine on port 80. I don't have anything running on port 80. But if I were to change this to scanme.nmap.org, then we'll have that same result. Or if I change it to another host, like I'll just do www.google.com. So again, there's that same, my local IP, some randomized port, and then here's one of the IPs for Google, and then port 80. So that's slightly more complicated than the other one. Going to the next one, see on this one. All right, so this was my first attempt at a lot of this beginning code is the same. So I defined a constant, and I'm just gonna loop through from port number 1 all the way up to port 4096. And a lot of this code is similar here in the middle. I've just wrapped a loop around it to go through ports 1 through 4096. And as you'd expect, this is going to be like crazy slow because it's going through ports 1 all the way to 4096. Let me change this. Depending on how patient we are, we may not even see a result. So there's one there. So it did connect to port 22 on that host. It did connect to port 80 on the nmap.org host. But as we saw earlier, like when I ran with nmap, these were like the only ports that are going to connect. And when I run nmap, these I would have already had the results back by now. So this is going through all those other ports, just 1 through 4096. It's never going to hit any of those other ones. In the interest of time, I'm going to stop that, and then we'll go on to the next example here. Let's see. So in that last example, it would work, but everything was very sequential. It was taking forever. Like if I would have let it go, it would have been several minutes. So in this next example is pretty similar. Like you saw in that previous example, it was kind of frustrating not to see the output. So I added a debug flag here, and it's just going to print out debug testing port and then list the port number. So you'll have a little more sense of what it's doing. And a large portion of the other code here is the same. You still have the net dial. You have me printing out the local address, the remote address, and then the normal error handling. So let me run that. And I'm going to pass it a debug flag. And so in this case, we'll see, these are all the ports it's testing. You should see them scrolling across. But when it comes to one, it does print out the information, like it printed out the information on port 22 and port 80. But as you see, this should go through 1 through 4096. This is one of the things I was seeing when I was kind of doing this all at once. Like right now, it's on port 135 and it's kind of stuck. So that's why I was wondering earlier, is like I need some way of saying why. I need some way of seeing what the progress is there on here. I'm gonna let this run for maybe a second or more, and I'm gonna Control-C this one. So this is one of the things I'd be curious on why I'm seeing this just stall like this. If anybody has thoughts, I would suspect this would start in this loop and just run through them one at a time. But like in this case, you've seen it seemed to stop at port 135. If anybody has thoughts, I would be open to chatting about it, or thoughts on why that happens. I'm going to go ahead and Control-C that. All right, and then this next example, the book walks you through this pattern of setting up a wait group to start down the road of doing this concurrently. So in this this version here, I created a new function called scan. You pass in a string and for the host name and the port, and basically it just the same code as from before. It prints out the local address, the remote address for that host on that port, and then handles the error. And then the addition here was this wait group, and then wait group done, I added that. And then you'll see down here a lot of this code is the same. I'm going from ports 1 through 4096, but I'm adding a 1 here, wait group that add 1. And then I'm using a go routine I'm using a go routine here with scan to do these in parallel. And then this wait group that wait here will wait until all the go routines are done. So this was a very similar example of what the book did by introducing a wait group and introducing go routines to do this in parallel. So I'll go ahead and run this, and we'll see. Hopefully this one is a little more performant. So in that case, you saw, unfortunately, like in this one, it's doing all 4096 go routines at the same time. You saw it shot through all these pretty much all at once. And this is not the way you want to do it, but it does seem to speed things up, but it's still got to wait for all those network connections and go routines to finish. But I did get my results back quicker, but this still is not the most optimal way. So the book kept on like iteratively making better solutions. So the next version, we still have the wait group in here. We still have a similar function, but we added a channel here, channel for the ports in the string. So you'll see stuff. Let me see in here. A lot of this code is the same. I'm trying to think where I'm using the channel there. Let's see. This version, this may just be an interim version that I did not completely use. So let's see. All right, make the channel there. The same flags are used. Again, I reduced the number of ports from 4096 to 1000. Let's see. I still have the debug. All right, so there's where I'm adding stuff to the channel. And then I have the wait group that waits still at the end and the close. So this is a little more efficient way of using wait groups and go routines if you introduce the channel on here. So let's run this one. the solution's getting better, but I think this one, see, I'm still thinking I still had something wrong with this version because I'm not using that channel at all. But again, it goes through and tells you that it's testing all these ports. Get it out of debug mode. But you definitely get your results quicker than before. It's still not as quick as Nmap, but it's much quicker than before. And all these new concepts to me, like that I'm mentioning here from Go, channels and Go routines, these were new to me. So if there's suggestions on how I can do this better, I'm all ears. And then I'm going to show you the final version that I had here. And it's going to be similar. So in this example, I added a channel to catch all the results for the scan. It's just slightly more complicated. I mean, if I make a connection to the port, I'm going to add the port number to the results channel. Otherwise, I'm going to add a 0 to the channel. And then here you'll see the ports was the previous channel that we used. Results is this new channel. And then this is open ports is just the slice of open ports. So the number of ports is, again, at maximum of 1,000. I'm going to loop through these. And then in this case, I'm using another Go routine here to loop through the number of ports and then put the port in the channel. And then this here is basically going through this list and adding any of the open ports onto the slice. And then at the end, I close the ports, I close the results, I sort that slice of open ports, and I just print them out. Mm-hmm. So you'll see this example is probably pretty close to Nmap.
Do that later.
Sorry, did someone have a question?
Very detailed, but squash.
What's that? All right, so hopefully we'll see here in a second. Again, it's not as performant as Nmap is, but it should get some results here in a sec. Maybe. Wait a second. Let me switch back over to my markup doc. We should see, I did this earlier today, we should see, sorry if I'm making you dizzy by scrolling around, trying to find where I was at. We should see in a second, we should see something here where it just says port 22 is open and port 80 is open.
Did I mention I get motion sickness? No.
Sorry, yeah, I was scrolling all over there. But
the
doc on my end is enormous, so it's like I see probably the individual characters are several inches tall.
And I was going to mention when you were talking about with the channels and all that stuff. Well, the concurrency is going to be next month's talk. So,
oh, nice.
Just a little plug.
Yeah, I may ask the person presenting next month on some pointers here. So, it did finally come back. I'll run that same. If I do that same nmap command, you'll see it'll probably run much quicker. Yeah, see, I mean, that was a couple seconds to compare to maybe upwards of a minute on mine. So I get similar results, but again, I would still like to know maybe what the difference is. I mean, Nmap is a professional program that's been around for quite some time. It's like the go-to port scanning program out there. So, but I mean, it was more of an educational experience for me. Maybe not creating the most optimal tool, but kind of just the journey of learning something. If you somebody has some suggestions on how to improve this more, that'd be great. Or if somebody's written maybe a port scanner before, has some ideas, I would love to learn more. Any questions at this point?
I haven't seen any. I think everybody's just being shy. Nobody wants to get invited to the screen.
I mean, I'm happy to answer questions. Or somebody says this is horrible code, feel free to tell me. Or if you want to praise the code, that's fine too. I think it's probably somewhere in the middle. It's not great, but it's okay. It does get results. So if there are,
what counts.
What's that?
I said that's what counts, right?
Yeah. I mean, yeah, I tend to be a pretty pragmatic person. I may not have like the ultimate, most robust solution at times, but I do get things done. So I think that's one of the things I liked about Go. I mean, and it was pretty easy to make this. I had very little prior experience doing Go. So while I was reading the book, I was picking up concept as I was going. If there are no further questions, I'll go on to the next tool that I looked at. This was in chapter 5 of the book. And it was I kind of modeled it after the tool Amass. It's another, man, I messed up these headers. It's like I switched them. So this is the DNS enumeration tool. The other one was the TCP scanning tool. So yeah, Amass is another DNS enumeration tool, which basically you give it a domain name, and it basically goes through and lists all the subdomains for a given domain name. Like in this example here, I looked up Microsoft.com. I trimmed all the output, but you're gonna have like in Microsoft's case, they're like close to 35,000 subdomains that they have that this tool discovered, and I wanted to do something similar with that. I mean, the resulting tool against Microsoft.com, and again, I trimmed the output here. It came back with all these subdomains, like obviously www.microsoft.com, mail, SMTP, M. These are a lot of the more popular subdomains that every domain probably has. So again, the user guide for the Amass tool that I mentioned here, the Git repos here, the code that I worked on is here, and then I'll go through the example, kind of the same examples I did for the port scan utility. I'll go through and start out with the very basic stuff that I started out, and then we'll get a little more complicated as we go along. So for the first example, I tried to, this is a little bit where I deviated from the book. The book used a third-party DNS library that was maybe a little more capable, but I kind of wanted to stick with the standard library as much as possible. I used the net package, and they had went off and used a different DNS library that provided it allowed you to look up all sorts of DNS records, like MX records, C records, A records, all the other normal DNS records that you have. And it would also allow you to specify the DNS server to use. Like in this case, the net package is only going to use like your local, whatever your operating system has as the DNS resolver, where I couldn't specify, well, I want to use Google's DNS, or I want to use another DNS server that I have locally. So in this case, I deviated a little bit from the book. I stuck with the standard library net because it worked well for me. So in this case, I just say, I look up Microsoft.com. If there's an error, print it out. Otherwise, just print out all the IPs for Microsoft.com. So let me go back up to the example. So in this small example here, I'm just going to print out So these are all the IPs in no particular order for Microsoft.com. Pretty simple. I mean, it would be similar if you used like host Microsoft.com. You should get similar results. So that would be very similar to just host or NSLOOKUP, any other dig or any other DNS utility. The second one here, I think it's going to be, yeah, it's very similar to my first one, but knowing that I was going to need a function, so eventually down the road I would need a function as I made this more complicated. So I just stuck the code to resolve the host name into a function here. So if I run this again, this one's, surprisingly, it's going to pretty much be the same. It's just going to print out those 5 or so IPs for Microsoft.com. And we'll start to see these get a little more complicated. So in this one, I knew I was going to need some sort of some set of word list or dictionary of names that I could try. So on GitHub at this site, I found a list of like the 1,000 most popular subdomains. And I stuck them in this file, subdomains.txt. I made a new function. Made a new function. I'm basically going to loop through the subdomains.txt, and then I'm just going to append it onto a slice, and I'm going to return that slice. And then this whole code, doing this like one line at a time, is probably silly. I could have just read the entire file at once and returned it. So this is something I could improve on. And then my resolve function is a little more complicated. So it's just not looking up a single subdomain like on Microsoft.com. It's going to look up a series of subdomains. So I'll pass in the slice, and then I'm going to just loop through the slice and then do the resolve for that slice. So in this case, run that. So this is it's still a little slow. So I mean, so each case, these are finding Microsoft domains, and then it's printing out their IPs. But again, it's still doing it sequentially. So the word list was like 1,000. So it's going to run through 1,000 of these. And if the name resolves, it'll print out the IPs for it. There's a lot of those in that word list that are not going to resolve. So it'll just pass over those. So this is a step in the right direction. It's basically enumerating all the subdomains for Microsoft.com that are in my word list. Like I have a pretty small word list. You could make the word list as big as you wanted. I mean, I have 1,000, but I've seen some of these programs like a Mass, they allow you to have a pretty large word list. So this version seemed to be doing pretty much what I wanted, but again, it's doing things very, very inefficiently and sequentially. So the next version, I think this next version is exactly the same. It looks like I just added a debug flag to kind of get more information as I was going through here. It's still basically opening the word list, looping through the word list, still returning that slice. See, in this case, I'm still doing everything sequentially here. So this next version was just adding a debug flag, it looked like. Where was my debug? Trying to see where I was using that debug. Okay, so if I have it in debug mode, in this case, I'm going to print out those IPs. Otherwise, I'm not. Otherwise, I won't. So like in this case, if I ran it without debug, the output would be a little better. So it's a little easier on the eyes. It's still reading through these sequentially, but you're just getting the subdomain .microsoft.com now. But it's still pretty slow. But you'll see there's still quite a lot of these that it is resolving. And I'll go on to the next one. If there's no questions. All right, so this one, again, these should feel very similar. I'm just changing small things in here as we go. Trying to think of this one. I'm trying to notice the changes. Oh, goodness, let's see. Still got the flag. So in this case, this was my first attempt just to make sure that these were all in functions, because I knew that in the next few examples I was going to use a Go routine to do these in parallel. So in this example, I'm just using a couple functions here to wrap up what all I had in main. So if I run this version, it's going to be very similar to what we just showed. It's just internally I'm putting those in functions. So in this case, it is resolving things. It's still doing things somewhat slow, and you'll see somewhat sometimes it does stop. But yeah, it's still doing things very slow, 1 through 1000, or the length of the word list. And let's see, I will go this final version. This is the final version that I worked on. Again, we have a lot of the same stuff. We have the list of subdomains. We have the debug flag, the domain flag. And I used a lot of the concepts from the earlier TCP scanner example. In this one here, I think I ran over it. Yeah, I still have the wait group here. So I'm going to use the wait group. In this one here, it was similar to the wait group that I added in the TCP scanner. I added a one here in the resolve subdomains function. Then I used the wait to wait for all the Go routines to return. So you should notice this one should be quicker. Should get through those quicker. So this gets it through pretty quickly. I could probably still improve this more, like it's spinning up all those Go routines at once, all 1,000 of them. If I use some like some kind of a worker pool, that would be a more efficient way of doing this. But this was close to what they had in the final version of the book project. See, that was pretty quick. So that went through all those in just a few seconds, this version here. And I mean, once you have enumerated all these domains, then you could use something like nmap or the port scan utility that I used earlier against some of these domains. Like one of these looks interesting, like security.microsoft.com or some other domain. You could use nmap or another port scanning utility to see what the open ports were on that subdomain for Microsoft.com or any other one. Like let me try another one I haven't done, like Facebook.com. That should be pretty fast. See, you get immediate results. Like you find all kind of subdomains for domains pretty quickly. Again, I could probably still improve this more. Like if I put some worker pool in there, that would make it more efficient instead of spinning up all these at once. I'm kind of amazed with Go. It'll still might not be the most efficient way of doing it, but it allows you to get things done pretty darn quickly. So yeah, see that listed all the ones for Facebook.com. Apple.com. It should be very, very similar. So, I mean, you might wonder, like, oh, is this not the best practice to list all these subdomains? But I mean, these are all public DNS entries, so there's not. I believe there's nothing wrong with that. some. Now, if I were to go through and start port scanning some of these hosts, these are not obviously mine, so I'm not going to do that. I mean, it's kind of a gray area if you were to start port scanning some of these without asking for permission. I mean, people do it all the time, but I myself don't feel comfortable doing that if it's not something I own. So this was the final example here in the DNS enumeration example. Go back to my markdown doc. I think that was all the examples I had. There are definitely some areas I'd like to improve. Like as I got better with Go, I think just the use of Go routines, using those more efficiently, channels and wait groups. And the book examples kind of started out with wait groups and then they deviated away from those. So they might I wouldn't even need wait groups at all. It's one of those things that I think it was like an interim solution. And then in the final versions of the book, they took those out. So I may not even need wait groups. But so that was kind of the journey. I took a couple tools, a DNS enumeration tool and a port scanning tool, used the book as kind of a guide to develop those examples and learn a little bit more about Go and have a fun kind of side project that's somewhat security focused to work on. So I'm happy to answer questions. That's the content I had on those two examples. I can run more examples or I can answer questions. Anyone? I know what time it is. It's like 7.
Yeah, I'm not seeing anything coming through on the chat. I didn't notice anything in the Q&A. Anybody else? All right. Well,
I did have a question, actually.
Yeah,
yeah, you can hear me now. Do you know if there are nmap bindings available for Go? I know there are some bindings in other languages, so you could call nmap directly.
Yeah, I've used it in Python. I haven't seen that for Go. That's a very good question. I wouldn't mind looking, but yeah, I've used the Python one before, but I haven't tried the Go one yet. Instead of reinventing the wheel here, that might be a good idea. I mean, you have Sabri, you usually have some good suggestions. Do you see anything I was doing like just crazy wrong, or do you see anything that was maybe I could have done better?
I think like the iterative approach is really, it's a good way to explain like your own sort of thought process, because I think most people who are new to Go would do exactly what you did, right? So you start at the simple and add additional features. Like I think there's a lot of the tasks are very small, and so full on like Go routines per each may be a bit too heavy, because so even though they're very lightweight, that might not be enough of an operation to warrant an entire routine just for that one thing. So it might, you can get into like some funky sort of like, maybe you can chunk or shard the work into like maybe like 100 lookups per channel or something like that.
Right.
And that would maybe make better use of the multi-core. So that would be like the next sort of like, can we make this faster thing? That would probably, yeah.
Yeah, I mean, I was amazed. I kind of naively did this, and I was still amazed by it did it pretty darn well, pretty fast. But probably, I don't know, it'd be interesting just to try to do it in some scripting language like Go or like Python or Ruby, to see if I just naively did it without really trying to optimize it, if I still got decent results.
And we had a question come in about Chuck was asking if anyone's complained about scanning them that you know of. I mean, I know I was the victim of scanning once back in 2001. That's another story, but
yeah, I remember this was in my undergraduate degree, I had done something similar to this. I'd written a Java program that did port scans, and I did it against some university machines, and then I got threatened with being expelled, and it's not a good thing. It's like that's probably why I err on more being cautious than being brazen. Maybe probably based on that early experience. So, I mean, this is just my opinion. I try not to mess machines unless I have permission or they're already mine. So I just try to play the safe route, I guess.
Yeah.
There is a Twitter page called Bad Packets Report, and they will report like mass scanning activity. So if you do things that are too broad and too stupid, you may find yourself on that Twitter. So don't do that. But yeah, there are folks who are tracking like large scale scanning activity. Generally, at least from my experience, like if you're going to do any like serious sort of like professional bug bounty type of things, you have to go through the scanning and all that fun stuff. So a lot of these companies will already have like agreements and like, or sort of like reasonable, if you're doing this for a bug bounty or like bug hunting purpose and you aren't being dumb, fine. But unless you're doing that professionally, I would err on the side of you don't do it.
Yeah.
Some major companies will have like separate services specifically for pen testing. So you kind of have to figure out like what their policies are before you're just like scanning stuff without permission.
Cool.
Yeah, I think that's good sound advice. It's like get permission first, play it safe.
Yeah. I don't think there's anything else coming in, but well, cool. All right, well, thank you very much, Michael.
Oh, you're welcome.
Oh, yeah, easier to ask forgiveness, right? Yeah, cool. All right, well, let me see if I can't get us switched back to my slides.
Yeah, if I run into everyone at a future meetup after the whole coronavirus scare, I'd glad to talk about this more with somebody in the future if you want.
Yeah, and then and actually, yeah, you're Sabri just shared the that Twitter link, and then Chuck, somebody already put your the links to your repository are there in the chat as well.
Oh, nice.
I don't know if you shared that elsewhere anywhere, but yeah, so those are up and available.
Yeah, definitely feel free to look at it, or if you have suggestions, open up a PR or ping me on Slack or Twitter.
All right. Well, it looks like we've like reached a limit or something. So here, let me. Hopefully, I don't do anything bizarre. So I got to close out this screen before I can share my screen. And yeah, so apparently, I guess Crowdcast has a 4 limit or something. But yeah, so let's see. All right. So we are back. There we go. Yep. Don't pay attention to my wife outside. So that's one of some of the beauties of getting to work from home nowadays. So anyway, but yeah, so no, thank you very much for that. And then, just for everybody that's still on here, please, give us some feedback, how things are going. If there's anything different, any particular topics or whatever that you'd like to see us present on. And actually let us know what you think about this, this Crowdcast. I'd be kind of curious. Like I said, GoBridge is going to be hooking us up with something going forward. But yeah, we'll see. I don't know if next month we'll be in using Crowdcast still, or if we'll be set up by them to use whatever other option that they're providing for us. But anyway, but yeah, definitely let us know Twitter. There's several avenues to get feedback to us. And then, yeah, so next month's session will be on April 22nd, and Sabri here will be giving a formal look at Go concurrency. And then, the CSP-based concurrency model. And I'm going to be dumb here. What do you mean CSP-based? What's up with that?
So there's a bunch of like process calculuses that anyway, but so Go concurrency is based off of a specific kind of concurrency called CSP. There's a really good Wikipedia article on it, and it's not a one-to-one match. It doesn't work in all of the places, but we'll be taking a look at like how Go sort of like maps loosely to CSP and what you can do around that. And it's going to be a lot of math, and hopefully people will find out. It's easy math. It's not hard math.
Okay. Yeah.
But it'll be great for people who are coming from like my background was primarily in like multi-threaded programming. Go concurrency is not that. And so even if you're just interested in like how Go concurrency visualizes from like how do you make things connect to each other and all that great stuff, it'll be useful. So but there will be some math which may excite some people. I'm hoping it will.
Good deal. All right, well, thanks guys, and that I guess we'll cut it there. Siju, I hope you enjoy all 6 pizzas that were delivered to your house, I'm sure. From our sponsors, but anyway, hopefully everybody stays healthy, and then we can get past all this stuff, and hopefully munch. There we go, and then hopefully we can meet all live again. So I don't know. So anyway, thanks everybody. I'll send links to the video, so in case if you want to watch it over and over and over, maybe it'll help you sleep, maybe it not. I don't know. But anyway, I'll put some links out there. So anyway, thanks again. We'll talk to you guys next time. Bye.